In question 5 on the practice exam, we'll be creating a seasonal forecast, and we've got some data to work with here in two parts. As you can see on the screen, we've got the part A, normalize the following seasonal averages. So we've got 4 seasons: fall, winter, spring, and summer. And we need to calculate a seasonal average and then normalize that if necessary. And then we will apply those seasonal averages to our time series down below here and calculate then the deseasonalized sales. Okay, so let's start with that at part A here. So we've got to work with our table in part B to calculate our seasonal averages, and the way we're going to do that, we're going to be working here with the ratio to moving average column down here, which is very happily already calculated for us. And so to do that, then if we look at these values here, so we've got, it looks like eight values here in this column, okay? And we're going to be finding all of the ones that are for fall. We'll start with that. So we've got fall and fall, okay? And so we'll take those two values. We've got 1.018 plus 1.059. Okay, and average those. Divide by 2. Okay, and when we do that, then we get a seasonal average of 1.039. So we say 1.039. Okay, so that's our seasonal average there. So then we just move on to our next one, winter. So winter and winter. Okay, so we do the same thing there. We're going to add 1.028 plus 0.999 over 2. And then for winter, then we get 1.013. 1.013. Okay, and we do the same thing for spring. Put those in triangles, or sort of, so we can kind of keep that straight. We've got 2 of those as well. And so for spring, we've got 0.962 plus 0.980 over 2. Okay, and that comes to 0.971. 0.971. Okay, and then summer, we're going to do the same thing. We'll add those up, and the result that we get for summer is 0.978. Okay, so when we add these ones all up, and if we have 4 seasons, right, we should have 1, 2, 3, 4. Right, we've got 4. The sum of these of seasonal averages should be 4, but in this case we get 4.001. Okay, and so that means we need to normalize that to make this sum up to 4. And the way we do that is we divide 4 seasons over this sum here, 4.001. That's going to give us something very close to 1, but slightly less. Right? And so if we do that, we say 4 divided by 4.001, 0.9998. Okay, and then we're going to then multiply that by our seasonal average. Right? So it's going to reduce each of those very slightly. In fact, the only one that will reduce here is this first one. So if we say, because of rounding, right? We would say 1.039 times 0.9998 is going to then be 1038. Okay, so it just slightly reduces this. And the rest of these, for all practical purposes, are the same. 1.013. We multiply these out, but again, because of rounding, they're going to be about the same. And 0.978. And then these will all sum to 4. So that's how you know that you've done it properly. If these all sum to 4, then you'll be in good shape. Okay, so we've completed now part 1, or part A, I should say, and now we will then use our normalized seasonal averages, these values here in this column, and bring them down to apply to part B of the problem, which is this table here. And what we will do is, so what this in effect does, if we look at this, it means that in fall, when we use this, in fall our sales are slightly above average as they are in winter, and in summer and spring, right, because they're less than 1, they're going to be slightly less. So to deseasonalize the average, to smooth it out in effect, we will divide our forecast or our results here in this column, our time series data, we will divide by our seasonal average. So what that will have an effect of doing here in fall, right, so if we look at our fall, we will divide 152, let me get some more room here if I can, move this up a little bit, okay. So for that first one, we will divide 152, right, this value here, by our normalized season average, 1.038. When we do that, we get, so 152 divided by 1.038 is 146.4. 146.4. So even though our actual result was 152, because we know that that's a little bit higher than usual, right? We have some demand in the fall for some reason. We then deseasonalize that, divide by our seasonal average, the normalized season average, and that brings it down, and that would have an effect of, so instead if you had a chart here of sales that was shooting up in the fall and coming back down and so on, or even shooting up in the fall and winter and then coming back down and then coming back up in fall and winter, right, it would have the effect of smoothing this line out, right, so that you weren't coming up so high, and then so that will help you get a better idea of where you're heading in terms of your sales in this case. All right, and so if we do this down the column here, we would have 162. Now we look for the winter season average, 1.013, 1.013, and that is then going to be 159.9, 159.9. And so then that will and then we can do the same thing for spring and so on. And so if I make this a little bit larger, it might make it easier for you to read what I'm putting in here, but I'm just going to repeat that operation. Divide each of these values here by their respective seasonal average, normalized season average, up above from this table right here, right? And fill in that column. And so what we end up with here then is 161.7, and then 170.8, and 175.3, 189.5, 196.8, 201.5, 209, 206.3, 208.1, and finally 226 for our last one. And so if we look at this, then let me just zoom out a little bit maybe. Okay. And again, looking at this, we're trying to put this in some perspective here for part B. As we talked about, our sales in fall and winter here are higher than average. They're lower than average here. And so what we see then, we see this 152, 162 in these first results here. And then spring and summer are brought back down, although there's even slightly increasing here. And again, so it's hard just looking at the actual numbers, knowing that there's a seasonal effect, to get the idea of where these are. But the fall and winter, right, our deseasonalized ones will have the effect in fall and winter of bringing that number down because they're over 1. And then in spring and summer, because these are less than 1, that will have the effect of increasing these values here. So this is 157 here, and then deseasonalized, it would be 161.7. And 167 here becomes 170.8. So again, this takes seasonal out of them and gives you a smoother picture and a better trend line of where your sales are headed in this case. Okay, so that's part B. Part C is a short answer here. If you created two sales forecast models as part of your analysis, you would conclude that the model that had the best fit had the lower MAD, the higher R-squared, or the higher correlation. Okay, and so as you recall, we looked at MAD and mean squares of errors, looking at the absolute difference between what your model predicted and your result. And so that here would be what we're looking for. If you're comparing two models, you'd look at the one that had the lower MAD as the better model. Again, assuming that you've got something that's statistically significant and so forth, and you would look at that and say, okay, that's a better fit.